Hey, welcome back. We are going to look at the part 2. This one is going to be kind of short, but like I said, I want you to join me for the other one that's not in Math Nation because it has a little more in depth on some of the proofs. Okay, so we are looking at side, 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 and side, angle, side. So they're giving us some information, and what we're going to determine here is what is left that we need in order to prove that we have congruence. In this case, what information do we need to prove that these two triangles are congruent by side, side, side? Well, I have one side, I have another side. Okay, so we need a third side. So that is going to be, we need to know if this side over here is congruent, and we need to know if this side over here is congruent to each other. So we need to know if RG is congruent to CL. So what I'm asking you to do is start thinking of what is it that we need? What do we need here to prove that these two triangles are congruent using side, angle, side? Remember, where does that angle have to be? It has to be between two congruent sides. Okay, so they've given us one congruent pair and the angle. Okay, so what we need in order to prove it's congruent by side, angle, side is we need to know if those sides are congruent to each other. So we need to know if DS, segment DS, is congruent to segment RO. Make sense? So now let's take a look at this parallelogram. Looking at the parallelogram, we're going to prove this by side, 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 or we need to figure out what information is missing to prove by side, side, side. First thing we've got is they're telling us that this side of the parallelogram is congruent to this side of the parallelogram and nothing else. But there is something that we do know, one side that is congruent, and this would be the CS. Okay, see, it is part of both triangles. So it is congruent to itself. So we can say that CS is congruent to segment CS, and that property is called the reflexive property. So basically what we're saying is when something is congruent to itself, which at first doesn't make sense until you realize that if I were to draw these two triangles out, you would see that CS is in both triangles. Okay, so what is it that we need to prove that these two triangles are congruent? We've got two sides. We need to figure out, we need to prove that, I don't know, AS would be congruent to EC. We would still need that to be able to prove it. So that's what we need. Okay, we can't prove it unless we're told that they're congruent. Okay. And this right here, this is the reason why you're going to have some practice with some more proofs, because they only give us two, and that's not quite enough. Proofs are hard enough on its own. So some reminders about a proof. The given is always in the beginning. And you can either put it with the first statement, put them all in there, or the end. And what you're trying to prove is always the last statement. Okay, so again, if you can mark things up, that's great. So let's see what they're giving us and then what we would need to prove. So it says that CE is congruent to AC. So they've already marked that up for us. They said ER is congruent to AR. And we're trying to prove this. Okay, that doesn't tell us what we need to prove it. We need to figure it out. So we've got two different options at this point. We've got side, 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 and we've got side, angle, side. Well, I don't have an angle. They haven't given us an angle, but I do have a side. Look at that previous problem. What was in both triangles? Okay, and if I look down here, they already gave us a hint, the reflexive property. So right here, that line is in both triangles. So CR is congruent to segment CR because of the reflexive property. Okay, so I know that those two triangles are congruent to each other because of side, side, side. Okay, the side, side, side congruence postulate. Okay, let's take a look at number 5. Okay, again, they're giving us some information and we're having to prove that those two triangles are congruent. All right, but notice they are not giving us sides. They are not giving us angles. We have to kind of figure out what's going on. So again, with proofs, look at the given. If it's telling us that R is the midpoint of A to G, midpoint means middle, which means that this part right here is congruent to this part right here. It's also saying R is the midpoint of segment ET, which means that is the halfway mark between here and here. Okay, so again, they're giving us the midpoint. Why are they giving us that? So we can prove that two segments are congruent to each other. So I'm going to say GR is congruent to segment AR because of the definition of a midpoint. That's going to be the same thing at the bottom. RT is congruent to RE, definition of a midpoint. Now, I'm going to try not to even look at number 4, but I don't have any proof that GT is congruent to EA, but I do know that, and we learned this earlier this year, is that this angle right here is congruent to that angle right there because they are vertical angles. Okay, so angle GRT is congruent to angle ARE because they are vertical angles. Okay, so I have a side, an included angle, and a side. Same thing in the other triangle. So those two triangles are congruent to each other by side, angle, side. Again, 3 criteria to make them congruent. Moshi is making a quilt using the pattern and wants to be sure her triangles are congruent before cutting the fabric. She measures and finds that NV is congruent to VO. And angle N is congruent to angle O. So we got a side and an angle. Can Moshi determine if the triangles are congruent with the given information? What information would you need to know? Okay, well, I've got a side and an angle. I need another side. Do I have another side? No, I don't. So I do not have enough information. I need to know, now be careful. Side, angle, I need here. I need to know, is AN congruent? To be careful, I need to look at side then angle, so I need this piece right here. I need to figure out if AN is congruent to JO, or I need someone to tell me that they are. So no, I need this piece of information is needed. One last proof. I don't even know how to say that name, but she's a structural engineer. She is designing a tri-bearing truss for the roof of a new building. She must determine if the triangles below are congruent for the stability of the roof. If anybody knows how to pronounce that, please let me know. I just don't want to butcher it. All right, so I have in the given information that FM is congruent to FI. I also know that FR bisects angle MFI. So it's bisecting again. Let's take a look at what that would be. MFI. So that angle right there is bisected. Bisect means to cut in half. So that means this angle is congruent to this angle over here. Okay, so they're giving me one side, then they're giving me this piece of information. So what does it mean if that cuts it in half? It means that one angle is congruent to the other. That's the definition of a bisector. So they kind of gave us that information there. Then we also know that FR would be congruent to FR because of the reflexive property. So those two triangles, do we have enough information to prove that they are congruent? And if so, which one is it? Well, we already said earlier in the lesson that it can't be AAA because that doesn't prove congruence. But we do have a side, we do have an angle, we do have a side. So there's our answer. And that is it. Please join me for the other video.